In this episode, we focus on ethical guardrails, because AI systems can create harm even when they are secure in the traditional sense. A system might have strong access control and encrypted storage and still produce outputs that mislead people, reinforce unfair bias, or encourage unsafe actions. Ethical guardrails are the design choices, policies, and operational controls that keep an AI system aligned with human values and organizational responsibility while still delivering useful results. Beginners sometimes hear ethics and assume it is purely philosophical, but in AI security management, ethics becomes practical. It shows up in what the system is allowed to do, how it handles sensitive situations, how it treats different users, and how it behaves when it is unsure. Ethical guardrails reduce harm by constraining risk in predictable ways, and they also protect the business by preserving trust, preventing reputational damage, and keeping the system defensible to leaders and auditors. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good starting point is to define harm in a way that matches real AI use. Harm can include privacy violations, but it can also include misinformation that leads to bad decisions, unfair outcomes that disadvantage certain groups, or outputs that encourage dangerous behavior. Harm can also be more subtle, such as eroding user confidence, creating dependency on unreliable answers, or normalizing inappropriate content. Ethical guardrails exist because AI outputs can scale quickly, and a small error pattern can affect many people before anyone notices. Beginners often assume harm requires malicious intent, but many harms come from design choices that did not consider edge cases or vulnerable users. Ethical thinking in AI is therefore a form of risk management, because it asks what could go wrong for real people and how to reduce that risk before it becomes a headline. When guardrails are built early, they become part of the system's normal behavior rather than an emergency patch after harm occurs. Ethical guardrails must also meet business goals, which is where many teams struggle. Businesses adopt AI to save time, improve service, or make decisions more efficiently, and guardrails can feel like friction if they are poorly designed. The key is to build guardrails that support safe usefulness rather than blocking value. This begins with clarity about the system's intended purpose and boundaries. If the system is intended to support drafting, it should not quietly become a tool for making high-stakes decisions without oversight. If the system is intended to assist support agents, it should not be used as an unreviewed authority for customer answers. By keeping the purpose clear, you can tailor guardrails to the real business need and avoid overbuilding restrictions that make the system unusable. Beginners should see this as designing for responsible value, where usefulness and safety reinforce each other rather than compete. One of the most practical ethical guardrails is scope control, meaning you define what the system will do and what it will not do. Scope control reduces harm by preventing the system from operating in areas where it is likely to fail or where failure would be unacceptable. For example, if an organization cannot validate the model's reliability for medical advice, the system should not provide medical guidance. If the system is not designed to handle personal data safely, it should not accept or process sensitive personal details. Scope control also includes limiting integrations that would allow the model to trigger actions automatically, because automation can amplify harm when outputs are wrong. Beginners often think more capability is always better, but in ethical AI, controlled capability is safer and often more trustworthy. A system that does fewer things reliably can create more business value than a system that does many things unpredictably. Another essential guardrail is fairness awareness, which means you consider how outputs might affect different users and whether the system produces systematically different outcomes for different groups. Fairness is complex, but beginners can start with the idea that a system should not consistently disadvantage certain people because of biased data or biased patterns learned during training. Guardrails for fairness include careful selection of training data, evaluation that checks performance across different types of users and contexts, and mitigation strategies when disparities are found. This is not only a moral issue, it is also a business risk because unfair systems can cause complaints, legal issues, and loss of trust. Fairness guardrails also include being cautious about using AI for decisions that affect opportunities, such as employment or access to services, especially when transparency is limited. Beginners should recognize that fairness is a system property that must be tested and managed, not assumed. Transparency is another guardrail that reduces harm by making the system's behavior easier to understand and challenge. Transparency does not mean revealing every internal detail of a model. It means users and stakeholders can understand what the system is for, what kind of outputs it produces, and what limitations exist. It also means the organization can explain, at a high level, how decisions are made and what evidence supports trust. For example, if the system is likely to be uncertain or to generate plausible but incorrect content, users should be guided to verify outputs for high-stakes situations. Transparency reduces harm because it reduces over-reliance. When users treat outputs as suggestions rather than unquestionable facts, they are less likely to make dangerous decisions based on a single response. Beginners should see transparency as a safety mechanism that shapes user behavior, making the human part of the system more resilient. Another ethical guardrail is uncertainty handling, which means the system should behave responsibly when it does not know. A common harm in AI systems is confident incorrectness, where the model generates an answer that sounds authoritative but is wrong. Guardrails can reduce this by encouraging the system to express uncertainty, ask for clarification, or recommend verification when appropriate. The point is not to make the system unhelpful, but to prevent it from inventing facts in situations where correctness matters. This guardrail becomes especially important when users are novices, because novices are less able to detect errors. In business settings, uncertainty handling can be aligned with goals by making the system a better assistant rather than a risky decision-maker. Beginners should understand that ethical design includes designing for humility, because humility reduces harm and increases long-term trust. Privacy and data minimization are also ethical guardrails, because harm can occur when the system collects or exposes personal information unnecessarily. Ethical guardrails here include limiting what users can submit, masking or filtering sensitive data when possible, restricting retention, and controlling who can access prompts and logs. Ethical guardrails also include preventing the system from retrieving or revealing information that a user is not authorized to see. This is where ethics and security overlap heavily, because protecting privacy is both morally important and operationally necessary. A system that mishandles privacy can harm individuals directly and can harm the organization through loss of trust and regulatory exposure. Beginners should see privacy guardrails as part of the system's moral contract with users. If users share information, the system must handle it with care. That moral contract is what makes AI adoption sustainable. Human oversight is another guardrail that is often misunderstood. Oversight does not mean a person must approve every output, because that would destroy usability. It means the system is designed so that high-impact decisions are not made without accountability, and it means there are escalation paths when outputs are risky, ambiguous, or potentially harmful. Oversight can be risk-based, meaning more oversight for higher-risk uses and less oversight for low-risk uses. This aligns with business goals because it preserves efficiency where risk is low while protecting users where risk is high. Oversight also includes monitoring and feedback loops, so the organization can learn from real usage and fix recurring problems. Beginners should understand that oversight is not a lack of trust in AI. It is a recognition that AI is probabilistic and context-dependent. Oversight is a guardrail that keeps responsibility with humans when consequences are serious. Another important guardrail is misuse resistance, meaning the system should not be easily manipulated into producing harmful outputs or revealing restricted information. Misuse can come from outsiders trying to exploit the system, but it can also come from insiders who push boundaries or use the system in ways it was not intended. Guardrails for misuse resistance include strong identity and access controls, safe defaults, monitoring for abuse patterns, and constraints on what the system can retrieve or execute. These guardrails reduce harm by limiting the system's ability to become a tool for wrongdoing. They also protect the business because systems that can be abused tend to become liabilities that must be shut down or heavily restricted after incidents. Beginners should recognize that ethical design includes anticipating bad behavior, not because everyone is bad, but because some people will test limits and the system must remain safe under that pressure. Guardrails also need to be measurable and reviewable, or they will drift into slogans. It is not enough to say we value fairness or we value privacy. You need evidence that controls exist and that they are operating. That evidence might include validation results, monitoring reports, records of incident handling, and documentation of how sensitive data is protected. Reviewing guardrails means checking whether they still fit current use, because business goals and system scope can change over time. A feature that was safe in a small pilot can become risky when rolled out widely. A model update can change behavior, requiring new safety tuning. A new integration can increase the risk of harmful automation. Ethical guardrails survive when they are treated like operational controls with owners and evidence, not like principles posted on a wall. Beginners should see ethics as a practice, not a statement. To close, building ethical guardrails that reduce harm while meeting business goals means designing AI systems to deliver value within clear boundaries that protect people and preserve trust. Guardrails include scope control, fairness awareness, transparency, uncertainty handling, privacy protection, risk-based human oversight, and misuse resistance. These guardrails are practical because they shape how the system behaves, how users interpret outputs, and how the organization responds when things go wrong. They also support business goals because trustworthy systems are adopted more sustainably, create fewer crises, and remain defensible to leaders and auditors. Ethical guardrails are not a brake on innovation when they are designed well. They are the steering and seatbelts that let innovation move fast without hurting the people it is supposed to help. Task 3 is about making those guardrails real, measurable, and durable across the life cycle, so AI remains useful and responsible at the same time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.